Okay, so I'm going to talk in this video about system diagram analysis, and you should be able to do the following. Given the system diagram, find the system functional, find the impulse response, find the z-transform, find the poles and the ROC, region of convergence, write the impulse response as a sum of discrete exponentials, and find the system response to simple signals. Okay. So this is for a discrete system. Later we'll talk about continuous systems. So I thought I would give an example here. So here's an example. Okay. Oops, sorry. So it's this example. Okay. And let me go ahead and copy it, and we'll see what we can do to analyze this. Okay, so I will copy, and we'll move it down here. Actually, I'm going to move this down a little bit, and then I'm going to copy it and make another copy here. Okay, all right. Now, I mentioned before that there are some steps here. There's a systematic way of doing this. Okay, so systematic procedure is to, first of all, you want to label the nodes. Okay, and label outputs, and then write equations. Okay, so those are the three steps. Okay, so this is my diagram. I made a copy down here. So first I want to label the nodes. Okay, now the nodes, there's a node here. There's a node here. So I'll call that W. And there's a node here. I'll call that U. Now you might say, why isn't this a node? Well, it only has one thing going in. This has two things going in. So nodes are where you have two things going in. This is also this here is also not a node because I only have one thing going in. All right. So nodes are where you have more than one thing going in. Okay. So let me just make that clear. Okay. You don't have to label the ones that only have one arrow in. All right. Now I did forget something here. Usually when you have a system like this, you'll have a minus. So I'm going to put a minus here. In the diagrams he gives, he either specifies plus or minus, but I'm going to say that these two are minus. So let me make sure that I have that same thing here. There's a minus here. Sorry. Minus here, and then there's a minus here. Okay? All right, so let's go ahead. So now let's go ahead and we'll label the outputs. All right. So what do we have here? We don't have to label all the outputs really, but just the ones that are helpful. You can probably get away without labeling outputs as you gain more experience. Okay, but this here is going to be what I have out here is going to be 1/2 r squared w. Right, because there's only one input. It comes through this multiplier, this r squared, and it comes from w. Okay. Now actually I can label the output of this as well because this is just 2r times 1/2 r squared w. So this is going to be 2r times 1/2 r squared w. Okay, that's the output here, right? Because that was the only input from here. This u is not an input. This u here is not an input into here. The only input into here is from this arrow here, right? So. All right, so let's label another output. This output here, the only thing that coming out here is going to be 1/3 RU. So what I have coming out here is 1/3 RU. I think I can do that. Okay. All right, and what that means is that if I take my R back here, the arrow here shows me I'm going in this direction. So this is going to be 1/3 RU times R. I can just write that as 1/3 R squared U. Okay? Right. So now I'm ready to write equations. I'll do that in orange. Okay, so I have the equations. And there should be an equation for each node and for the output. And that way I'll be able to eliminate all the node variables. All right. So what about W? First of all, what about W? Well, I really have two inputs into my W node. I have from X, and I also have from here. So I have W is equal to X, and there's a minus, remember the minus, there's a minus, minus 1/3 RU. Okay? So that's for my first node. Then I should be able to get another equation for U. Right? So U, what is U equal to? Well, U has two inputs. It has the input from here, and it has the input from here. All right? So I can simply write that as a sum of two equations. So that's 1/2 R squared W minus, and then 1/3 R squared U. All right? Okay, so I have equations for two nodes. I also have an equation for the output. And the equation for the output is right here. Y equals, and I can combine these. The 2 and the 1/2 go away. So this just becomes R cubed W. So that's good. All right. Now, so what I want to do is I want to eliminate now the intermediate nodes. The nodes, and my two nodes are U and W. Okay. Now, from this equation here, I can actually eliminate the W. I can write this as W equals R to the minus 3 Y. Now, in the end, you don't want to have negative powers on your R, but temporarily I can write it this way. Okay, so that gives me my W, and I can replace that into these equations here, and then I'll just have the U left. Okay, so I'll have W. So let's replace that here. So I have R to the minus 3W minus 3Y is equal to X minus 1/3 RU. Sorry, RU. And then the second term I have U equals 1/2 R squared, and I'm going to replace my W again with R to the minus 3Y. And then I have minus 1/3 R squared U. All right? So I'm almost there. I have my X and my Y in my first equation here. So what I'd like to do is eliminate the U using the second equation. So I'm going to solve the second equation for U. Okay, and that's not that bad. I can take the minus 1/3 R squared U to the other side, so I get, I have two terms, 1 plus 1/3 R squared operating on U is equal to 1/2. Now the R squared cancels two of those, so I have equals 1/2 R to the minus 1 Y. Okay. So that's going to give me U in terms of Y. This is probably a pretty complicated example, but I think that's everything. Right? I got my left-hand side, my right-hand side, so we're all good. Okay, let me plug that into the first equation now. Okay, and we're just about there. So we have R to the minus 3Y. Okay, so you can see this is systematic. You just have to follow through the procedure and do the algebra. Minus 1/3 R, and then my U is here, 1/2 R to the minus 1 Y over 1 plus 1/3 R squared. Okay. So just to write that again, I have r to the minus 3y equals x minus, let's see, the r's cancel, and the 1/3 combines with the 1/6, so I have 1/6 y over 1 plus 1/3 r squared. Okay. All right, so let's take the y to one side, and I can write this as 1 over r plus 1/6 1 over 1 plus r squared over 2 over 3. And I apply that to y, and that's equal to x. Okay. All right. Now if I put this over a common denominator, I'm going to get what? I'll get 1 plus r cubed over 3. Sorry. Okay, 1. It's okay, hang on a second. We'll get there. I get on the top. Let's try again. All right, here we go. 1 plus, let's see, I can do this, I suppose. 1 plus 6. How do we do this? 1 plus r squared over 3. Okay, and then I say it's plus r over 6 divided by r times 1 plus r squared over 3 times y is equal to x. Okay, so finally we take it the other way around, and we get y over x, and we invert this here, and we get r times 1 plus r squared over 3 divided by 1 plus r over 6 plus r squared over 3. Okay?